Hello everyone, today let's solve the problem number 15, 3 sum. So what the question states here, given an integer array nums, you can clearly see we have been given an integer array nums. We have to return all the triplets nums of I, nums of j, nums of k such that I not equal to j, I not equal to k and j not equal to k, and nums of I plus nums of j plus nums of k equals 0. So this is the very important part, and we cannot make use of the this one same number. Here you can clearly see I not equal to j, I not equal to k and j not equal to k, they have mentioned here, right? So here this one. So I hope this is completely clear. Let's come to the first part here. First example here. Sorry, just give me a second here in this case. So here we have been given the nums array 1 0 1 2 minus 1 minus 4. So in the question they have clearly said that we cannot make use of the same number, right? Means minus 1, again we cannot make use of the minus 1 for the triplet here. The same number, if duplicate is present, that's fine, we can make use of it. Here minus 1, we have already been given minus 1 twice here. We can use this minus 1 again, but the same number we cannot use this one, right? So that's what they have given in the question. So this is fine. So nums, this one triplet means 3 numbers. When we sum up 3 numbers, the value has to be or the solution that we have to get has 0. Those triplets we need to return. See here we have minus 1 plus 1 2 minus 1 4, also 0. Sorry, 0 I forgot here. So minus 1 and 2 will lead to 0. So minus 1 minus is minus 2, minus 2 and plus 2 will lead us to 0. So this is one triplet we can consider here, minus 1 and 2, and one more triplet here is minus 1 0 and 1, minus 1 0 1. So minus 1 plus 0 is nothing but minus 1, minus 1 plus 1 is 0. This will lead to 0 as well, and we can consider this triplet as well, right? So these are the two triplets that we need to consider that will lead to 0 from the nums array in the first example, right? So I hope this is completely clear. Let's come to the second example here. Here in this case we have 0 1 1 and we have the empty array. Why? Because the only possible triplet that sum up to 0 here is so there is no possible this one triplet that sum up to 0 here. That is the reason in that case we need to return this one empty array, right? This is fine. So third one here is 0 0 0 we have within the array. So the only possible triplet that sums up to 0 is 0 0 0 itself, right? So we can consider only 0 0 0. 0 plus 0 plus 0 is nothing but 0. The only possible triplet here, right? I hope this is completely clear. So they have mentioned the examples beautifully here. So I hope the examples are completely clear. I hope the question is completely clear and what we need to do is completely clear as well, right? So first thing here is we will be discussing the approach followed by the edge cases one by one, and then let's write the code and discuss the complexities for the code that we have written. Initially, let's discuss the let's discuss the approach step by step. The first thing that we need to keep in mind here is we will be going with the 2 pointers plus sorting, or we can just say 2 pointers after sorting. After sorting we'll be making use of the 2 pointers, right? So we'll be going with the 2 pointers plus sorting approach, right? So just keep this in mind. So I have considered the first example that they have given in the question so that it will be easier to understand. We have already discussed this one. So we have to return all the triplets that will lead to the solution 0, right? So when we sum up that one, that should lead to 0. In this case, minus 1 minus 1 minus 2 plus 2, this will lead to 0 as well. Minus 1 plus 1 0, 0 plus 0, this one will also lead to 0. This is fine, right? So in this case these two triplets will lead to 0. That is the reason we need to return this one in the form of output, right? So let's discuss the step-by-step execution on this case. So here the first example, the same thing I have considered here. First step is, as I have said, we will be sorting the approach. While discussing the approach itself, I said we'll be going with this one, 2 pointers after sorting, right? First step here is we will be sorting the array. So when we sort the array, we will get this one. When we will be sorting this one in the ascending order. So minus 4 comes first, minus 1 and minus 1 second, second, this one minus 1 comes third, fourth one is 0, fifth one is 1 and 2. This is the array after sorting, right, and the ascending order. This is fine. So the next step here is, sorry, just give me a second here. We will iterate through the elements with a fixed index I. This is very important. So we will iterate to the elements with a fixed index I, and we will be making use of the 2 pointers. We will be making use of the 2 pointers here. So we'll be making use of the 2 pointers here, L and R, to find the pairs, right? So we'll be making use of the 2 pointers L and R to find the pairs here in this case. So let's see the first iteration here. First iteration here, I equals 0, means nums of I equals minus 4. I equals 0 in the sense, so this one, the first index, 0th index, this is 0 based indexing, right? So array is 0 based indexing. So we'll start from I equals 0. So I equals 0, after sorting the array, this is 0, right? This is 1, this is 2, this is 3, this is 4, this is 5, this is fine, right? 0 based indexing. So we'll start from I equals 0 in this case. So first what we will do here, I equals 0, nums of I equals minus 4, we know that one. So left L equals 1 and R equals 5. Just give me a second here. L equals 1 and R equals 5 in this case, right? So this one, L, R equals 5, right? So L equals 1, R equals 5 in this, R equals 5 in this case. Nums of L, nothing but minus 1, and nums of R equals 2 here. Just give me a second here. Nums of L, this one, minus 1, and nums of 2 here is, nums of 5 is nothing but 2 here, minus 1 and 2. So minus 1 and 2. So when we sum up this one, 4 plus of minus 1 plus 2 will lead us to minus 3, right? We are summing up this one, 4 minus 4, as we are nums of I is minus 4, and this one we are considering minus 1 and 2. So this will lead to minus 3, and minus 3 is less than 0. Then we will move L. So why this has to lead to 0? If we have to consider the triplet, so the solution has to lead to 0, right? Here we got minus 3, which is less than 0. So we will move, or we will increment L here in this case, left pointer. So when we increment the left pointer here, now L will be 2 here in this case, this one. So again L will be minus 1. So again L will be, L will be minus 1 here. So this one I'm speaking of. Nums of L will be this one, minus 1. L equals 2 in this case. So L equals 2. This one I'm speaking of. L equals 2, right? This one, indexing I'm speaking of. L equals 2 and nums of L is minus 1. As we have incremented the L, nums of L is minus 1 and nums of R remains same. Nums of R equals 2 itself. So here now we sum this one. This will be 2 minus 1 and 2. 2 minus 1 and 2. This one will be 4 minus 1 will be minus 3, right here. So this one somewhere I did wrong. Just give me a second here. So sorry, here I got confused. So nums of I is minus 4 itself. This one itself we have to consider again, right? So L became 2 here, but nums of I is still 4 itself, right? Minus 4 itself here. In this case, minus 4 minus 1 is nothing but minus 5. So minus 4 here, this one, and this one we are considering. Again, minus 4 minus 1 is minus 5. Minus 5 plus 2 is minus 3. We got minus 3 again. So minus 3 here we didn't get 0 again. So minus 3 is less than 0. Then again we will move L here in this case. So if I come here, then again we will move L. Here now L will be 3 and nums of L will be 0. So nums of I will be 0, right? So I'll just come here in this case. Let me come here. So L is 3, nums of L is 0. R remains 5 itself. R remains 5 itself here. R remains 5 itself and nums of R, the last one, 2 itself. This remains same. R equals 5 and nums of R remains same. So this will be minus 4 plus 0 minus 2 sum minus 4 plus 0 minus 2 here in this case. So sorry, plus 2 here in this case. So this will lead to minus 4 plus 0 is minus 4, minus 4 plus 2 is minus 2. So minus 2, again we didn't get 0 here, we got minus 2. Minus 2 is less than 0. Again we will move the left pointer here. Left pointer, I'll just come here in this case. Left pointer, we will move to 4 and nums of I becomes 1 this step. So here in this case, nums of I becomes 1 now. Nums of I became 1 now, right? So here in this case, nums of L became 1 now. Sorry, this one L became 4 and nums of L became 1 now. So R and nums of R remains same. R equals 5, nums of R is 2. So when we do this one, when we sum up this one, minus 4 plus 1 plus 2. So this will lead to plus 3. Minus 4 plus 3 is nothing but minus 1. So minus 1, again we didn't get 0 here. So minus 1 is less than 0. Again we will move L plus plus. So here again we'll increment the L in this case. So this now L is equal to R. So when L is equal to R, we will stop. So when L is equal to R, we will stop, right? So here we will stop. Why we will stop? Because no triplet has been found here, right? L is equal to R, so we will stop here. No valid triplet is found here. No valid triplet is found. So let's come to the iteration 2 here. When I is 1, I itself is 1. So when I say I itself is 1, so this one I'm speaking of, I is 1, right? So here in this case, I is 1. Just give me a second here. 6 1, right? Yeah. I is 1 and nums of I becomes minus 1. The next number. Nums of I, till now, nums of I was basically minus 4. This one we are considering right here, minus 4. This time, nums of I becomes the next one, minus 1. So this one will be nums of I, main one. Nums of I will be minus 1 this time. So let me come here. In this case, I will be 1, nums of I is minus 1. So L equals 2, R equals 5. So we'll consider L equals 2, R equals 5. Nums of L is minus 1 and nums of R is this one, 2. So 1, when we sum up this one, 1 minus 1 plus 2, right? Here, sorry, minus 1 we have to consider. Minus 1 plus 2. Minus 1 as nothing but minus 2 plus 2. This has led to the 0, the value 0. So when this has led to the value 0, we will be adding this one, this triplet, right, to the array. We will be adding this triplet to the array. So the first triplet that led to 0 is minus 1, 2. So as we have got this one, the solution 0 here, so we will move the left pointer and we will increment the left pointer and we will decrement the right pointer. Now L equals 3 and R equals 4. So this one I'm speaking of. Now L equals 3, this one. So now nums of I itself is this one, right? We have already considered this one. So now L equals 3. I'm speaking of this one. Let me make this one R. So second step. Now L equals 3 and R equals 4. This one will be R, right? So let me come to this one. L equals 3 and R equals 4. So here nums of L will be 0 and nums of R will be 1. The same thing. Value we are considering. That's it. Nums of L is nothing but this one, 0 initially. Nums of R, we are considering this one, 1, 0 and 1, right? So we have considered 0 and 1 itself, right here. Yeah, 0 and 1. So the first step here is when we sum up this one, so we have minus 1. Here, this one I'm speaking of, minus 1. So minus 1 and L minus 1 plus 0 plus 1. So here, yeah, minus 1 plus 0 plus 1. This will lead to 0. So triplet minus 1, 0 and 1 we have to add to the array because the solution we got here is 0 when we summed up minus 1 plus 0 and plus 1, right? So here this is fine. These two things we have added. Next thing, let's move on with the iteration 3 here. I equals 2 and nums of I is -1 again here. So here in this case, nums of this one again -1 we got here, right? So this one we will consider this time. This one will be considered as nums of I. Previously we considered this one. First time we considered this one as nums of I. Then we considered this one as nums of a -1. And third time we are considering this one -1. Sorry, not this one. This one -1 itself. So this one got repeated again. So we have already done for -1. This one got repeated again. The -1 is getting repeated again. So what we will do in this case, we will skip this one. We will skip this one to avoid the duplicate triplets. So we shouldn't go with the duplicate triplets, right? We will skip this one to avoid the duplicate triplets. So iteration stops here basically. So the final output that we got here is this one. -1, -1 and 2, -1, 0 and 1. In the second step, if you remember this one I'm speaking of. -1, 0, 1 and this one. -1, -1 and 2. These two things. We got these two triplets which will sum when we sum up these numbers which will lead to 0. -1, -1, -2, -2 plus 2, 0 and -1 plus 1, 0 plus 0 is 0. Right? So this is the final output. The output that we got and the output that they have given for the example 1 is same. -1, -1, 2, -1, 0, 1. So this is the output that we got is equivalent to the output that they have given for the example 1. So the approach works absolutely correct in this case, right? So the approach works absolutely correct in this case. So what we will do here is now we are familiar with the approach. Let's quickly discuss the edge cases. Let's quickly discuss the edge cases here, right? So the first edge case here is just give me a second here. All the negative numbers, right here. So here the output is empty array. Why the output is empty array? You can just write out in the same way that I showed for by considering the example 1, right? So I can just write out. So here you'll get no combination basically. No combination gives some 0 here. So we are returning the empty array. Same goes with the second edge case as well. For all the positive numbers here 1, 2, 3, no combination will give us the sum 0 here. So we will return the empty array in this case. Let's move on with the third edge case here. Array with duplicate elements that form multiple valid triplets here. So with duplicate elements means we have here, see, these are the duplicate elements here, right? So here that form the multiple valid triplets. In this case, we get the triplets. You can just write out in the same way that I showed for the example 1 if you want to know how we got this output, right? By this time you have to be familiar with the approach. We are familiar with the approach. You can just write out in the same way. -2, 0, 2 will lead us to 0 and -2, 1, 1 also. This -2 plus 2 will lead us to 0. So these two triplets, right? These two triplets will lead to 0. So the output that we need to return here in this case is -2, 0, 2, -2, 1, 1. This is for the condition array with duplicate elements that form multiple valid triplets. And the fourth edge case, let's come to the fourth edge case or the final edge case here is array with only zeros. Valid triplet that is possible here is this one. So here only valid triplet is 0, 0, 0. We have already discussed this one in the example, I think, the second example, I think. In the question itself, they have given the same thing, right? So this is for the condition array with only zeros. These are the 4 edge cases that we need to consider. First one was for all negative numbers. Second one was for all positive numbers. Third one was for array with the duplicate elements that form multiple valid triplets. And the fourth one was for array with only zeros. These are the edge cases that we need to consider. Now we are familiar with the approach and we are good with the edge cases as well, right? Now we are familiar with the approach as well as we have the idea on the edge cases as well. As we are familiar with the approach and edge cases, it will be easier to write the code now. Let's start writing the code. So now let's quickly write the code. First step is, if you remember, we have to sort the array, right? So we have to sort the array in the ascending order. So I'll just go with here arrays dot sort of. We have to pass the nums here, right? Nums array we have been given. So I'll just pass the nums here. This is fine. So next step is we have to store the result triplets. So I'll just make use of the list here. Let me go with here list. Basically, is of the type integer, consists of the integer. This is fine. So result, this one, we have to store the result triplets, right? So this one, let's make use of the array list here. New array list. This is fine. So the next step here is, let me initialize n2. We'll be making use of length of the nums. So I'll just initialize this one to n. So this one multiple times we'll be using. Instead, we'll initialize this one to n and make use of it later, right? N equals nums dot length. This is fine. So second step, if you remember, we have to iterate through the array. Why? Because we have to within that one we have to skip the duplicate elements, right? We have to skip the duplicate elements. That's what we need to do. For first step here is, first thing is we will iterate through the array. I'll just write the simple for loop here. Int I equals 0, I less than n minus 2 I'll give. Let's increment the I here. This is fine. So within this one we have to skip the duplicate elements. So I can just write the simple if condition here. If I greater than 0 and nums of I during, while explaining the question itself, I had said we shouldn't make use of the duplicate elements, but if the elements is present again in the this one, what do you call an array, that we can make use of it, right? The same element we cannot make use of that one, right? So if I greater than 0 and nums of I, this one which is equal to nums of I minus 1, then if the elements are duplicate, then we have to we can just give continue, right? I can just make use of the continue keyword here. Nothing but we are just skipping the duplicate elements here, right? So the next step here is, as I have said, after sorting we'll be going with the 2 pointers, or we'll be making use of 2 pointers. So I'll just go with here and L equals I plus 1 and another pointer is R, left and right, n minus 1 here. This is fine. We have just initialized the 2 pointers here. The first thing what we need to do, or the third step here, is we have to find the pairs using the 2 pointer technique. We have to find all the triplet pairs using the 2 pointer technique itself. That's what we have discussed during the approach, and we saw that one with the help of example 1, right? So first I'll just make use of while loop here. While L less than R here, in this case what we will do, so here I'll just give int sum equals nums of I plus nums of L plus nums of R in this case. This is fine. So if the sum is 0, then we have to add the triplet. In this case, we have seen this one in the approach. If the sum is 0, obviously we have to add the triplet, right? For that, I'll just write the simple if condition here. If sum equals 0, or if sum is 0, then we have to add the triplet. I'll just be making use of this one, add property. So I'll just go with result.add of arrays, sorry, not as, we are making use of as list, right? This one will be nums of I, comma, nums of, let's increment the L here in this case, and we have to decrement the R, if you remember, right? So we were incrementing L. If you found the triplet, then we have to move to the next one, right? We have to move the left pointer to the next element and or the next index, and we have to decrement the right pointer to the previous index, right? So that one we are doing here. This one will be R minus minus. This is fine. So the next step here is we have to skip the duplicate. So for skipping duplicates, I'll just write the simple while condition here. While L less than R and nums of L, this will be equals to nums of L minus 1. This is fine. We have to skip the duplicates in this case. Let's increment the L as well. So we have to skip the duplicates from left pointer, and we have to skip the duplicates from right pointer as well. So I'll just copy the same thing. Let's do the same thing for the right pointer as well. So I'll just come here. Instead of incrementing the right pointer, instead here we have given L plus plus. We have to decrement the right pointer, as we have to move left, right, from right to left. So we will be decrementing the right pointer. In this case, I'll just give left less than right. this remains same, and nums of r here, instead of nums of r, equals nums of r plus 1. This one, let me change this one. This is fine. So this remains same. Let me decrement the r here. This is fine. We are skipping the duplicates from left and we are skipping the duplicates from right. That's what we did here in this case. This is fine. So the next case here is, the next condition is here, we have to move the left pointer if sum is less than 0. So while discussing the approach, we considered first example. First few times we got -3, -3, -2, -1, right? So in that case, what we did, we moved the left pointer. Means we incremented the left pointer, or we moved the left pointer to, by one step, if you remember, right? That's what we need to do here. That's what we need to articulate the same thing in the form of code. So I'll just give here, else if sum less than 0, then what we are doing here, we are moving the left pointer if sum is less than 0, right? So in this case, else if sum less than 0, then we have to increment the left here. This is fine. We have to increment the left. So else, if the sum is not less than 0, else we have to move the right pointer if sum is greater than 0. We know this one, right? So if sum is greater than 0, we have to move the right pointer. In most of the cases, for the first example, the sum was less than 0, if you remember. -3, -2, -1 and all we got, right? So we in else what we have to do, we have to move the right pointer if sum is greater than 0, right? I'll quickly write this one, else. So here in this case, let's decrement the right pointer. The final step is we have to return the final result, right? So this one, in this case, yeah, this one, let's return the result. So this is it. So here we have what we have done here. We have successfully written the code, right? I'll just format this one and let me hit the run button. So we have error here. So line number 8. Oh, again, this is Java, man. Just give me a second here. Yeah. Line number 15. This one again. Let me delete this one. This is fine. And yeah. Now let me hit the run button. So yeah, you can clearly see here the sample test cases are getting passed. Let me hit the submit button quickly. I hope this works for all the test cases. Let's see. So you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case. All the test cases are getting passed. Means the code works absolutely correct in this case, right? So let's quickly discuss the complexities for the code that we have written. First thing here is the approach that we went with here is two-pointer technique, that is after sorting, or we can just consider two-pointer plus sorting, or we can just say it as two pointers, right? So the approach that we went with here is two-pointer technique after sorting. So what will be the overall time complexity here? The overall time complexity is big of n log n. Why? Because sorting plays the dominant factor here, right? Sorting takes big of n log n, and each element is processed within a two-pointer, that is big of n. So sorting is the dominant factor, we know that. So overall what happens here is big of n log n plus n square. So here big of n log n plus n square we are going with, right? So overall time complexity would be here in this case big of, not big of n log n here, this will be big of n to the power of 2, n square, sorry. So sorting takes big of n log n, and each element is processed with two-pointer approach, nothing but in this case big of n. So overall it is big of n log n plus n square, which will lead to big of n square. Sorry, I got confused here. So overall time complexity would be big of n to the power of 2 or n square. So what will be the space complexity here? The overall space complexity would be here in this case. Just give me. So here the overall space complexity would be big of 1. Just give here big of 1. Why it is big of 1 here? Because excluding the output storage, we are making use of only constant extra space, right? So we are just making use of the constant extra space. So overall space complexity would be big of 1 here, right? So for the output storage, then so we know that k is nothing but number of valid triplets here. If we consider the output storage, it will be big of k, right? So space complexity would be big of 1 here. So overall time complexity would be big of n square, and space complexity would be big of 1 in this case, or for the code that we have written, right? So I hope whatever the code that we have written is completely clear as well. For now, this is it. Thanks for watching, guys.